All right, so in this video, we're going to take a look at a few more examples of limits of functions. And so we'll start here with this first one. Limit as x approaches 0, absolute x over x. First thing we always do is plug in the number, which in this case gives me that 0 over 0 indeterminate form again. And so in the last video, I pointed out we would now need to manipulate the function to try to reevaluate. But this is one where it's not really going to be the case. And so what I'm going to do is now rely on our ability to graph. This is actually a piecewise function. If you take this absolute x over x, there's only two possible outcomes. You could get a 1 or a negative 1. And I would encourage you to plug some numbers in to see that. For example, if you plug a 5 in, well, 5 over 5 gives you 1. If you plug a negative 7 in, that would give you a positive 7 over negative 7, which would be your negative 1. And so, in this case, we're going to get 1 when x is bigger than 0, and we'll get negative 1 when x is less than 0. Remember, it can't equal 0. So, now when we put our graph together, you'll see that anytime our x's are positive, we get a 1. And anytime our x's are negative, we get a negative 1. And so there's the graph of our original function. Now, remember in the last few examples, I was very, very careful to say that if we're approaching 0, which we are, I drew it on there coming in from both directions. And that's the case in this particular problem as well. If we approach coming in from both directions, we get different answers. If I come in from the right-hand side, my y value is 1. But if I come in from the left-hand side, my value would be negative 1. And so the answer to this, because the negative 1 and positive 1 aren't the same, my answer to this particular limit is does not exist. DNE does not exist. If you get different answers approaching from different directions, your overall limit does not exist. More to come on that later. Okay, so then for the second example that you see up on the screen, we're going to approach positive 1 now. And you can see I would start by taking the 1 and plugging it in, which would give me a 1 over 0. Well, that is not an indeterminate form. 1 over 0 is not. 0 over 0 is, but 1 over 0 is not an indeterminate form. So there's got to be something else going on. So once again, I'll rely on our ability to graph. And this is a graph that we could put together from our college algebra days. And at x equals 1, you can see that would actually be a vertical asymptote. X equals 1 due to the domain. I also can see that no matter what, my function is going to be positive, with our horizontal asymptote here being at y equals 0. My graph then has to be entirely above the x-axis. So again, that's our college algebra method of graphing, kind of simplified and condensed down very quickly. But either way, now if we have our discussion about approaching 1 from both directions, you can see as I approach from the left and the right, I'm ending up at the same place. I'm ending up at positive infinity. So the answer to this limit is going to be positive infinity, again, because both sides end up at the same place. All right, so for our next problem, it's going to be a little more complicated. We're going to have to rely a little more upon our algebra and being able to simplify. And that takes us to our limit laws on page 48. I would encourage you to pause the video and take a little bit of time reviewing those limit laws on page 48. They have 7 of them listed. And it's not so much that we're going to use every single limit law in every single problem, but it's a matter of knowing that they exist and knowing where the limit is allowed to go. You'll see in certain problems it's going to be far more helpful to apply these concepts. In certain problems it's not really going to be worth our time because we're just going to treat the function as a whole. But know that they're there, know that they exist, and know that you can use them when necessary. The book has a couple examples following that theorem on the bottom of page 48 and on the top of page 49. So let's go ahead now. And before I even plug the 0 in on this one, first thing I'm going to do is I'm going to go ahead and condense it all down into one single expression. one single big functional unit. And so what I'll do is I'll go ahead and I'll leave the 1 over t off to the side, and then I'll build up an LCD there in the middle. That'll be a 3 minus root 9 plus t over 3 times root 9 plus t. And again, that's just with an LCD putting it all together. Finally, I'll go ahead and multiply the 1 over t in, and that's going to give me a 3 minus root 9 plus t over 3t root 9 plus t. Okay, so now I'm at a point where if I reevaluate, since I have everything condensed down, if I reevaluate, you can see very quickly you'll get that 0 over 0, which is our indeterminate form. And now I need to manipulate the function. And so to do this, I'm going to go ahead now and multiply the top and the bottom by the conjugate of our numerator. So essentially I'm rationalizing our numerator. And so we've done this before. It shouldn't come as a surprise, but it is going to be a very common technique when it comes to these limits. So I'm going to multiply top and bottom by 3 plus root 9 plus t over 3 plus root 9 plus t. Carrying that limit notation down. Remember, you got to carry that all the way down until you evaluate. When I multiply now my numerator, because they're conjugates, that's going to give me a 9 minus the quantity 9 plus t. And in the denominator, I'm going to leave it as 3t root 9 plus t times 3 plus root 9 plus t. We don't want to distribute that in there. Remember, if we're going to evaluate at 0 and get an answer, we can't have that t right there. And so distributing it in here and here wouldn't make a whole lot of sense, wouldn't help us out. So limit as t goes to 0. If I distribute the negative in my numerator, that leaves me with a negative t over our denominator, 3t root 9 plus t times 3 plus root 9 plus t. Now the t's are able to be divided off, and we have our limit as t goes to 0 of negative 1 over 3 root 9 plus t times 3 plus root 9 plus t. So since we were able now to get rid of that t, we're at a spot now where we can reevaluate. And so I'm going to take the t going to 0 and plug it in, and you can see for a final answer I get the negative 1 over 54. So again, all I did was I plugged that in. So that's going to be a negative 1 over 3 times a 3 times a 3 plus 3. So 9 times 6 would be that 54 in the denominator. And so there's your final answer. So again, I didn't really use limit laws. Know they exist, know that they can be applied when necessary. But at the end of the day, most of these larger limits, it's going to be just a matter of manipulating the function algebraically so that you can reevaluate at the value we're approaching.